Hey folks, welcome back to my channel. My name is Hunor, and in this tutorial we are going to code a watch with SVG and JavaScript. For a while, we can inline the code of an SVG image right inside HTML. This opens up a lot of cool options. Suddenly, we can access parts of an image from JavaScript or set the style from CSS. We can animate parts of an image from JavaScript or make it interactive. Or we can turn things around and generate graphics from code. In this example, we are going to use SVG to paint a watch and use JavaScript to animate the hands. We also have a calendar window showing the current date. This calendar window will be clickable. When you click it, it will switch back and forth between the current date and an AM/PM indicator. This tutorial is a bit more advanced example, going in depth with some of the less obvious SVG properties and focusing on animation and interaction with JavaScript. If you would like to get a more general overview of why you should care about SVGs, then check out my earlier video where we walk through the code of 24 simple SVG images. But if you start here, you're at the right spot as well. We will go through everything we use in this example in detail. So let's start coding. We start with a simple HTML file. We are only going to use plain HTML, CSS, and JavaScript this time. There's no need to use any bundlers or any other tools. Then let's start painting the watch. We add an SVG tag with a circle inside the body. We draw a red circle. The SVG tag serves as a container for our image elements. The markers, the hands, and the calendar window will be all within this tag. The SVG tag also defines the frame of our image. It sets the inner size and the outer size of the image. The width and height properties define how much space the image takes up in the browser. There's often a viewbox property as well. This defines a coordinate system for the elements inside the image. These two can be confusing, because they both define a size. Let's see some examples. Here all three SVGs have the very same content. A circle element with the same center coordinates and same radius. They appear quite different though. At the example in the middle, the size defined by width and height matches the one defined by viewbox. This means that when we say the circle should have a 50-unit radius, it will actually appear as a 50-pixel radius circle. Units used to define sizes within the SVG will be translated one-to-one. 50 units will become 50 pixels. In the example on the left, we see what happens if the width and height are smaller. The image shrinks down. The coordinates and sizes defined within the image still align with the viewbox. The 50-unit radius circle will be smaller though. Each unit will be half a pixel. Whenever we need to reduce or enlarge the size of an image, you only have to change the width and height properties. You shouldn't change the viewbox, as that is tied together with the image elements. We can see what happens if we change the viewbox in the last example. In this case, the viewbox is focusing on only part of the image. Things appear bigger in this case, but not because we enlarged the image itself, but because we only see part of it. Everything outside the viewbox is cut. The actual size of the image is the same as in the example in the middle, defined by width and the height property. The viewbox also defines the center of the coordinate system in which the elements place themselves. The first two numbers in the viewbox property define which coordinate should be at the top left corner of the image. Coordinates grow to the right and downwards. We can use this to center the coordinate system. By starting at the -100, -100 coordinate from the top left corner and still using 200 as width and height, we end up having the origin in the middle of the image. This will be our starting point. We have a 200 by 200 pixel image with the 0,0 coordinate being in the middle. And to fix our example circle, we change its center position to the 0, 0 coordinate. Moving the center of the coordinate system to the middle will have quite a few positive side effects. One is placement. When positioning image elements, we can relate them to the center of the image now. And the second benefit is transformation, or rotation in our case. By default, elements rotate around the center of the coordinate system. We can, of course, set another anchor point, but by centering the coordinate system, we don't need that. So this is going to be our starting point. But before we move any further, let's center the image in the page. At this point, the image should show up at the top left corner of the browser window. Let's add some style with CSS. We add the link tag to a style sheet. Then in our CSS file, we set a few things. First, let's set a background color. Then remove the default margin from the body tag. The body tag still comes with a default margin. That can shift things a bit when you try to center align them. To remove it, you have to set it to 0. Then to center things, we are going to use Flexbox. We set the display to flex and set the align items and justify content properties to center. Now the image containing the circle should appear in the middle of the browser window. Now let's start drawing the watch. We start with the hour and minute markers on the edge of the watch face. Then we add the hour and minute hands that will point to the current time. We will use some JavaScript code to rotate them into the correct position. And finally, we will add the calendar window that shows the current day. This will also use some JavaScript. It will have an event handler that will toggle it between the current day and an AM/PM indicator. So let's start with the markers. These little lines that show the hours and the minutes on the side of the watch. There are multiple ways to do these. For instance, you can draw each line one by one. But probably the most effective way to draw it is to use a circle with a special dash property. Let's see how. We already have a circle element, but so far we haven't talked about it. Let's see what properties does it have and how to transform it into hour and minute markers. This circle tag has a center position, a radius, and a fill property. We define the center position by defining the x and y coordinates. If this happens to be 0, like in this case, then we can even remove these properties, as 0 would be the default. Then we set the radius with the r property. The radius is half of the diameter of the circle. To have the circle almost fill the image, let's set it to 90. And finally, the circle's color is set with the fill property. You can think of it as background color property in CSS for HTML elements. But unlike in HTML, here we have to use the fill property. SVG often has similar properties to CSS for HTML elements, but these properties often have different names. One of these differences is to use the fill property instead of background color. We don't actually want to have a filled circle though. Instead, we want to have a transparent circle with a border. So first, we set the fill property to transparent or to none. We have to set it explicitly to one of these values because by default it would be black. Then we set the border. Here's another difference. We don't set the border color property, but the stroke property to set a color. Stroke is not only used for borders. If you draw a line or a path, then you can also set their color with the stroke property. Then to make it appear, we also have to set the stroke width property, similar to border width. Now here's where things get interesting. How do we turn this into minute markers? You might be familiar with the border style property in CSS. Mostly you would use a solid line as a border, but you can also have a dotted or a dashed border. These border styles are not very common, as you don't have many options for fine-tuning them. In SVG though, we have similar possibilities with much more customization options. we can use the stroke-dasharray, stroke-offset, and the path length properties. Let's have a few examples. First, let's add a single number to the stroke-dasharray property. This will result in a dashed border where the line segment and the gap both will have the same length, the length we defined in the stroke-dasharray property. This property, though, is an array. You can set multiple numbers here. If you set two numbers here, then the first one will be the length of the line segment and the second will be the length of the gap. You can even set more than two numbers, and then the length of the line and gap will always be the next number until it runs out of the array and it starts from the beginning. We will set two numbers, one for the length of the minute marker and one for the gap between two markers. The sum of these two should be exactly the length of 1 minute on the circle. How exactly should we set these numbers so that in the end the line segments match the minute markers? We know that 1 hour is 60 minutes, so we can calculate the circumference of a circle, then divide it by 60 to get the length of 1 minute on the circle. Then split this number into two parts, the part of the marker and the part of the gap. But there's a better way. Instead of calculating the circumference of the circle, which depends on the radius, we can go the other way. We can set a number that acts as the circumference of the circle, then use that in our calculations. We can set the path length of the circle. The interesting thing is that this property will not resize the circle. The actual size of the circle is still defined by its radius. This property, though, affects how the dasharray property is interpreted. The dashes will be drawn as if the circle had a circumference defined by path length. So let's set the path length to 60, representing 60 minutes. Now the sum of the line and gap segment has to be 1 in total. In this example, I set it to 0.2 and 0.8. Now we are almost done, but one little piece is still missing. The dashing is a bit off. You might not even notice, but the dashing starts at the wrong position. If we would use much bigger numbers, then we would see that the dashing should be shifted by half of the line segment's length. We can do this by using the stroke-offset property. This will shift the whole dashing. It might be a bit counterintuitive, but a positive value here shifts the dashing backwards. You can also shift it the other way by setting a negative number. So as a result, for our minute marker, I set the stroke-dasharray to 0.2 and 0.8 and set the stroke-offset to half the line segment's length, 0.1. In the same way, we can set an hour marker. We add a new circle tag with almost the same properties. The only thing that's different is the color and the dash array. Hour markers are located on top of every 5th minute marker, so dash array will have longer gaps. We add 4 to the gap's length. It's important to note here that layering in SVG matters. Tags added later on in the document will be on top of the previous ones. If we added these two circle elements in the opposite order, then only the minutes would be still visible, as they would fully cover the hour markers. Before moving on with the hour and minute hands, let's clean things up a bit and let's move some of these properties to CSS. As the SVG lives in HTML now, we can set an ID or class to an element and set some of these properties from CSS. I set a class for both the hour and minute markers, then move the fill and stroke properties to CSS. We can move all the properties though. There's a difference between properties defining the style and defining the shape of an element. The radius, for instance, defines the shape of the circle, so it has to stay with the SVG code. The fill and stroke properties, on the other hand, we can move. This will give us some space in our HTML for our new elements. So let's move on with drawing and animating the hands. Let's add the hands that show the time. We start with the hour hand. The hour hand and the minute hand consists of two lines. A thin line going from the center of the watch to the 0-50 position, and a thicker line going from 0-12 to 0-50. We use the line element to draw them. To define a line element, we have to define the starting and ending coordinates, along with the stroke color and the stroke width property. To make things a bit nicer, we should also add the stroke line cap property that would make the line caps rounded. Before moving on to JavaScript, let's move some of these to CSS. We assign CSS classes to these elements and move the stroke, stroke width, and stroke line cap properties to CSS. Now here's the interesting part, animating the hand with JavaScript. If we assign an ID to an element, then we can access it and manipulate it from JavaScript. Which element should we assign an ID though? We have two elements now for one hand. To solve this problem, we can group these two line elements into a group tag. You can think of a group tag as a div element in HTML. On its own it doesn't do much, but if you set properties to it, they boil down to its children. In this case, we assign an ID for this group, then we can rotate the whole group into position from JavaScript. Then we add a script tag to import a JavaScript file. It's important that we add this tag after we created the image in HTML. You might want to add this script as the very last item in the body tag. You need this because the script will try to access this group by ID, and if the script comes first, then it wouldn't work. Alternatively, you can also move the whole JavaScript logic into an event handler that only gets triggered once the page has loaded. But this is a slightly easier solution. Then, in the JavaScript file, first we get the hand element by ID. We are going to set a rotation on this element so that it points to the correct hour. First, we need to get the hour and then figure out how we can translate that into rotation. We create a date object and we get the current hour. Then we set the element's transform attribute based on the hour. The transform attribute can include multiple transformations like scaling, translating, or skewing. We are setting the rotate transformation that requires a number. This number is a rotation in degrees. Therefore, it has to come between 0 and 360 degrees. We divide 360 by 12 to get how much rotation do we need per hour and multiply it by the current hour. This should turn the hour hand into the correct position, pointing to the current hour. Luckily for us, the transformation center by default is the origin, the 0, 0 coordinate. If this wouldn't be the case, we could set another transformation origin, but because of our view box settings, we don't need that. In a very similar way, we can do the minute and second hand. The minute hand is basically the same, except it goes longer. It goes from 0, 0 to 0-80. The second hand is even simpler. It's only one thin line. As second hands usually go, it has a little tail. It doesn't start at the 0, 0 coordinate at the center, but at the 0, 12, and it goes up till 0-80. The second hand also has a different color to make sure that it's visible. To finish up the design, we can also add a little circle in the middle. This is purely for design reasons, to show where's the center of the watch. Now back in the JavaScript file. Of course, we add a similar logic to move the minute and second hand into position. First, we get the elements by ID. Then we also get the current minute and current second from the date object. We use these values to set the transformation of the minute and second elements. The only difference is now that we divide 360 by 60, because 1 hour consists of 60 minutes and 1 minute consists of 60 seconds. Now this should already show the current time, but as you might notice, it doesn't update the hands as time passes. To keep up with time, we move the logic responsible for rotating the hands into an animate function, and use the requestAnimationFrame function to keep on calling it as time goes. First, we trigger it by calling requestAnimationFrame outside the animate function. Then, to keep on with the animation, we also request another frame at the end of every animation cycle. Now this should work. The second hand jumps every second, and if you wait long enough, the minute and hour hands should also move. If you want to have a smoother animation though, you can refine things. The requestAnimationFrame gets called around 60 times every second, so it would be a waste if you would only update the watch once every second. Instead of having discrete positions for the hands, we can define them in a way that not only pointing to an exact minute or hour, but they can also point between the minutes and between the hours. In this modification, the hour hand won't get its position only based on the hour, but it will have a slight turn based on the current minutes as well. The minute hand will also consider the current second in its rotation, and the second hand will also consider milliseconds. This way, our hands will have a continuous movement. They won't just jump from second to second, but they will animate. We reached the final part of the watch, the calendar window that will have an event handler that toggles the current date and the AM/PM indicator. First, we need to add a text element before the hand groups. In SVG, we cannot simply add text content to any element. We have to use the text element for that. Here I set 00 as a placeholder, but the actual value will be set from JavaScript. Also note that the order still counts. We don't want this to appear on top of the watch hands, so we have to add the text element before the hands. To define the text element, we need to set an ID to be able to access it from JavaScript and the X and Y coordinates. Now let's add some style with CSS. To set the text color, we have to use the fill property again. Then we can set a font family and anchor the text to the middle. This will set that the position we define with the XY coordinate will be in the middle of the text. This basically centralizes the text around the coordinate. This element will have an event handler, so we also set the cursor to pointer. And we can also set the user select property to disable text selection. By default, you can select text in SVGs just like from any other HTML element. Then back in JavaScript. First we do a similar thing we did before with the other elements. We get the text element by ID, get the current day from the date object, and assign it to the element. There's another minor difference from HTML here. Normally, you can set the content of an HTML element by setting the inner text or inner HTML properties. Here, to achieve basically the same thing, we have to set the text content property because the inner text and inner HTML properties just don't work with SVGs. This will show the current day on the watch face. And as a final step, let's add an event handler. We can add an event handler the same way you would add to any other HTML elements. We call the addEventListener function on the text element and pass on that we want to listen to the click event and an event handler. This event handler will toggle a top-level variable indicating if you want to show the date or an AM/PM indicator. This is going to be a boolean, which by default is true. In the event handler, we always set it to the opposite value. If it was true, then we turn it to false, and if it was false, we turn it to true. Then, as a final step in the animation loop, we not only get the current day from the date object, but also figure out if it's before or afternoon. Then we show either the date or the AM/PM value as the text content based on our top-level variable. Now if we check the result, we should have a smoothly animated watch, and if you click the text element, it should toggle its content between the current date and the AM/PM indicator. You can check that not the whole image is clickable, but only this small specific part of it. This opens up interesting options when you only want parts of an image to be responsive. Perhaps you want to create an interactive diagram that displays more data if you click part of the diagram. Or you can code your own game with SVG elements. The options are limitless. If you want to learn more about SVGs, then you can find many more examples in my previous video where we walked through the code of 24 simple SVG images. In that video, we start with some basic elements, then soon reach curves and the path element that we can use for drawing more advanced shapes. If you want to go through the code of the watch we built, then you can find the whole source code of it on CodePen. The link is below in the description. Thank you for watching. If you like this video, please subscribe and check out my previous tutorials as well. Let me know what you would like to learn next, and see you at the next one.